Welcome back, everybody.
Excellent.
I'm here with Russ. Russ and I were just discussing the horrors of U.S. customs, but I'm delighted to say Russ is not going to be talking about that. Talk about developing a culture of reliability and resilience through chaos, which I'm excited to hear. With that, Russ?
Excellent. Yeah, thank you, Bill. Hi, everyone. I am, first of all, hugely sorry that I'm not there in Vilnius doing the wonderful things you'll be doing in that locale. It's someplace I really miss, and I miss everybody that we usually hang out and enjoy the moments, particularly around the bar, probably a little too much around the bar, but wonderful times. So I hope you're all doing me proud and having a fabulous time without me. This talk is a relatively new one, and so I'm going to try it out on you a little bit. And I should probably put the first caveat on this being that I'm an engineer. I work currently as a lead engineer in a fabulous team of people distributed across the United States and mostly the UK. And as part of that team, my job is to encourage the sorts of habits, practices, and behaviors that help us be more resilient and reliable. But to do that, what I do is, rather than treat culture as a blurry, metaphor-driven possibility, I try to treat culture as a system, as a set of processes that we can affect. So this is kind of like engineering for culture, is what this is about. Because I don't know about you, as an engineer, when I see a talk that starts with culture in the title, my first instinct is sometimes this isn't for me. I'm more about engineering things. Well, this is about engineering culture to do some really valuable things. Okay, so who am I? If you don't know me yet, oh my goodness, are you in for a treat? I am Russ Miles. I've written several books, mostly on chaos engineering these days. I think I've written 6 books in total, but not all on chaos engineering. I don't generally recommend perhaps my early books, because everyone writes things in their youth that they regret. But then my later parts of my career, these are the better things I've written on. And they relate intimately to the topic of this talk, which is chaos engineering being one particular set of tools and approaches that underpin resilience and why we might want resilience in our systems. So I've written a lot of stuff. The latest one is I contributed to a fabulous book, which is literally called Chaos Engineering, curated by Casey and Nora. I recommend all these books to you. If I was there in person, I might even have a few copies to hand out. In fact, what I'll say to those of you that are interested, the first people that ping me either on email, LinkedIn, or Twitter, I will try and get you copies of this book. The first few people, I will get copies of one of these books to, whichever ones you fancy. Unless they've gone out of print. Any of my books gone out of print, I can't get to you. I'm sorry, just impossible. But give me a ping if you want one of those. That's a reason to take note of the links at the end of the talk. Okay, so developing a culture of reliability and resilience through chaos. Why would we even want to do this? Is usually the best place to start with anyone who says we should do things slightly differently. And I tend to frame this around some recent scientific evidence of what makes high-performing teams in software engineering and engineering products. The old idea in the early days of my career was that we were in a trade-off battle between reliability and speed. You can be reliable, you can have it working, or you can go quickly and it'll break frequently. And I think it's fair to say a lot of us are still there. That's pretty much how we still operate. If we're going to go really, really fast, we're going to cut the corners. We're going to forget about the good stuff we know we should do. Quality gets thrown to the sidelines because we're going quickly. But what's interesting about the research that I'm going to introduce you to in a minute, and I very recommend you take a deeper dive into, is that it's a false dichotomy. It's a false argument, speed versus reliability. What they found is that when you speed up how frequently you deliver, so this is deployment frequency in a given year, when you're delivering more frequently smaller pieces, when your lead time to change is low, your mean time to recovery is also usually low. So what that means is by going quicker, by delivering more frequently, by delivering increments that are much smaller risks, smaller pieces, we actually get both. We get to go quicker, we get to be more agile, which is also an important characteristic most people have invested in for the last 20 years. And we also get to be more reliable as well by changing how we think about reliability. So we can go faster and we can go more reliable. But it does require us to work differently. And what these slides don't show, and all of these slides, by the way, have come from a book called Accelerate. If you haven't read it, you will. It's absolutely fabulous. It's the sort of book I say to people, there's like 5 or 6 books in the world of software engineering you must read. Accelerate is one, team topologies is another, continuous delivery is another. Chaos engineering's got to be in there somewhere just because I wrote it. But these statistics have come about through many samples across the industry of what makes these high-performing teams. And it's been proven that by going quicker, you will actually be potentially more reliable, often more reliable. Because what we see is the failure rate due to change is low as well. That's the key one that tells us we're doing better. We're building more stable systems that deliver on reliability. Now, I'm going to be a bit careful here. What do I mean by reliability is something I sometimes get asked. And when I say reliability, I am primarily empathizing with the consumer of your system. They are the primary judge in my model of things of what is reliable. If they can literally say, I rely on what you produce, then they are judging it as reliable. That doesn't mean it doesn't have technical problems inside of it. Doesn't mean that the system occasionally has downtime inside of it. It may even have downtime observable to users. But if it's expected and it's there for them when they need it, then it's considered, I believe, reliable. So reliability is a measurement of the user's experience, the consumer's experience of the system you've got. And it turns out, again, the quicker you can move, the quicker you can deliver into production, the more reliable you're likely to be. And that starts to make sense when you consider mean time to recovery, because your chances are your recovery strategy is going to require you to deliver quickly. I've lost count of the number of times I've worked with teams where they have 2 ways of delivering into production. There's the normal way, which is months of lead time, sometimes weeks, but still, either way, pretty long lead time on anything. And then there's the, oh my goodness, we need to do it today, right now, this second, because things are on fire. Now, what's interesting about those 2 models, neither of which is sustainable, by the way, neither of which are pleasant, nor are they, as I would put it, kind to the users that are around the system or inside of it. Neither of those 2 things are the right answer. What there is a balance that says if we can move quickly, shouldn't we deliver quickly into production anyway as a normal course of action? And then we get the benefits of rapid response, benefits of mean time to recovery being low, but without it being a special case only for when things are on fire. So smaller batch sizes, more frequent delivery into production are both good key parts of doing this and getting these systems into a reliable state as perceived by the users. So now the argument goes, it's speed and reliability. I've heard this in lots of places, and I've joined us, as I say, this team at Segovia Crown Agents Bank recently to work on things like speed and reliability across the engineering team as a member of the engineering team. Now, one of the questions I sometimes get is, you've gone to this bank to work on banking things. Surely speed is not at the top of your list of possibilities there. And the truth is, it absolutely is. Now, one of the things we do is we make it possible for incredible organizations like Save the Children to send money to where it's needed in, I would say, hard to reach places like Africa, some of the African countries. So this is why I do the job I do. I have no love of banks, but I have absolute love for enabling great organizations to get money where it's absolutely needed. And the interesting part about that is that we have the same challenges. We need to be fast and reliable. Why? Because if tomorrow the UN needs to send money to Afghanistan, which I can guarantee you right now is a real use case, then they will need a mechanism to do so. It doesn't exist right now to do that. There aren't many banks that can say, we have the facility, the network to get your money to Afghanistan. Whereas we as an organization would say, right, if we can adapt and be quick enough and therefore be reliable enough as well, then we can meet that need. So speed and reliability for us, as for many other teams, is a differentiator as far as we're concerned. A commercial differentiator as well as a pure technical system differentiator as well. So this is why we bother with trying to develop a culture of reliability and resilience. I'll talk about how the two things relate in a minute, and I'll even define the resilience as well, because we've talked about what reliability means, but we haven't yet talked about what resilience means and how we enable that through chaos. Now, some of this is about chaos engineering, but really there's something more important in the mindset of chaos engineering that is closer related to resilience, reliability. So don't be turned off by chaos engineering. Don't be turned off by thinking we don't need more chaos. I want you to be turned on by the fact that we're going to be looking at how we make systems more reliable and resilient. And chaos engineering is just one example of that mindset in play and practice. Okay, so culture first. Let's hit the hardest word in the mix. What is culture? Lots of great definitions out there. One of my favorites is really very simply stated. It's the way we do things around here. It's what everyone is naturally aligned with and naturally behaves and acts. There's usually underlying principles that guide the culture. They may be explicit, they may be implicit. There's usually those principles are either in conflict or they are aligned with values that we probably all share as well. But the bottom line is the culture is really exhibited by a collection of behaviors that collectively define this is how we do things. And everywhere I've gone, I've seen different cultures. I've seen different people working in different ways, different tools and systems supporting different things. And what I'm saying here is that when you look at culture this way as being the how we do things around here, then it becomes something you can apply engineering thought to. We can engineer how we behave, how we work, once we understand that it's really the culture can be manifested as those behaviors that we want to tinker with and evolve. Because if you look at culture in terms of how it's defined, and it's one of those words, by the way, in English particularly, that is very, very broad. It can mean many, many different things to many different people, and a lot of culture is hidden underneath the surface of what everyone's doing. So I'm very careful. I say when I'm working with the culture, I'm trying to work with what we understand as being the values, the principles, the practices, essentially, eventually the behaviors and habits of how we do things around here. So when I say we're going to develop a culture, evolve a culture to reliability and resilience, I'm going to give you some tools to affect the behaviors that you work in and to see which ones might give you the most impact in your particular environment. So one of the reasons we have a culture at all is that we might want to learn from incidents, right? So while we think about culture, let's look at learning from incidents. Now, it seems almost a no-brainer to say, let's learn from incidents. And I think that's fair, but the amount of organizations that I see that try and do this that don't, I think it's worth hammering home. Most organizations I bump into do postmortems or incident analyses of some sort. But do they truly learn from it? Do they see these things as the minefield of possibilities? You know, it really is a treasure trove. An incident analysis is a treasure trove, when done well, of things to learn from. And I love that there's a measurement I've heard a few times now of what makes a really great incident analysis. Measurement of a good one is how many people are reading it. If you write one and it just sits on the shelf and no one reads it, then I guarantee you, you're not learning from incidents. You might be capturing them, you might be putting them in analysis, you might be able to point regulators at them, but you're not learning from them. And so enabling learning from incidents requires us to pay a cultural tweak. We need to understand, why would we learn from incidents? Why don't we just cover our butts by putting these things in a document somewhere? And we do this because another thing that I hear a lot is that we're learning from incidents, but really we shouldn't have incidents. I get that a lot. We just shouldn't have them. we're doing something wrong because we have incidents. Well, no, not entirely the case. All right. What's happening is we need to change the word incidents to what it really is, which is surprises. All right. Think about it that way, right? When everyone says, why didn't we know that incident was going to happen? That sounds like a rational sentence. However, if you change incident to surprise, which is what they are, then that sentence no longer makes sense. Why didn't we know that surprise was going to happen? Well, it was a surprise. We don't anticipate lots of surprises. We might be prepared for them, but they're still surprises and they're still going to happen. So getting better at surprises is one of the reasons we affect the culture. We embrace the fact that surprises are going to happen. This actually started off with the recovery-oriented computing project way back in the day. I thoroughly recommend you go and have a read about how that went down. And basically, it came from a very specific mindset, which is failures are going to happen. You're never going to prevent all types of failure. And these days, that's more relevant than ever. We have systems now that are built on complete houses of cards. We call those house of cards, by the way, the cloud. We build these things up and then we think they're going to work. And I've said this a few times in the past, but production environments are the place where your software is least likely to work. It's a hostile environment. The world doesn't want your software to run. And so when you take that perspective on production, then recovery is the right thing to optimize for. That's when we start saying, well, okay, how do we get better at recovery? How do we develop our behaviors so that our system and value our system in such a way that recovery becomes the goal? Prevention is not entirely possible because failures are inevitable. This is the basic principle of modern software system delivery, right? Your failures are inevitable. Don't consider them to be necessarily failures. They are learning opportunities. Okay, you're never going to be sufficiently designed for you to avoid all failures. This is the promise that used to happen way back in the day when everyone was doing UML models. And the reason I can say that is I wrote a book on UML. Like I say, we write things in our youth that we are surprised by. So, lots of design, lots of analysis, therefore we're going to get it right. And we've known that not be correct for over 20, 25 years now. That's where agility came from. We know we're going to get it wrong. We need a mechanism to get it more right over time, hence agility. In the case of system failure, it's the similar model. It will still fail. With all the best people, practices, and processes, a system is still going to fail under certain unanticipated conditions. So whilst it's incredibly valuable to architect and design, it's not going to save you from the problems. So because the basic thing is a priori prediction of failure modes is not a possibility. You're not going to be able to do this all before the event and know that you're absolutely ready for anything. And of course, we all know that human action is a major, I would change the word from source, but to be factor within system failure. We all play our part. But the important point here is you can't remove all human action because it's a creative endeavor that we're involved in. We want the intuition. We want people to be able to be applied and thrive when systems need their intelligence, their expertise. But if you treat them as something to be avoided, then you end up dumbing them down, making life hard for them. And so humans are a key part of the systems we build. They aren't necessarily something we can optimize out. Okay, so what we need then is a new way of looking at the world, new way of looking at the system, which is where resilience comes in. I mentioned reliability earlier being something that people measure as an experience of the system you deliver. Resilience is what we inject. We do resilience to make things more reliable. Resilience could be best understood as a collection of learning loops, of feedback loops. The more feedback loops we have and the faster they are able to react, the more resilient the system could be. And what we need to look for is what are the right measurements of these feedback loops to know that we're introducing them well into whatever system we're working on. And of course, by introducing feedback loops, we change the behaviors, we change how we work around here. So it is a cultural change as well. Okay, so let's look at developing a culture. When you're developing a culture, these are the things you play with, okay? Generally, you play with how the system actually works by observing it. You look at what the principles are in terms of what matters to everybody. Values, which are the why these things matter in the first place, they're the framing. And then the processes are, this is what we do around here. And at the center of this is practicing it. So because culture is changing behavior, whether it be technical behavior or individual people behavior, it's best practiced and repeated, right? So we need to make sure these things bed in as habits almost. And that requires consistent and constant sometimes practice. Okay, so resilience and reliability. As I mentioned, it's all about from the user's perspective. It's not about whether your system is healthy. I don't usually care if the system's healthy. I wish it was healthy. I wish it was, because it's less pain for us who are looking after it. But really, it's whether the system looks healthy to the users that matters the most when it comes to reliability. Resilience, well, we have to inject resilience because of this characteristic. So this is my favorite model of a system in production. In the foreground, you've got what you think you were designing, a nice green field, perfectly well developed, calm. The fences are there, the borders are there, everything's isolated perfectly. We're all good. It's secure, it's wonderful. And in the background, you've got your users. They are coming, and also not just your users, you've got the cloud conditions, you've got all of the turbulent conditions that hit a production system in the background there. And the key thing is here, you can't anticipate hugely in advance, design for in advance, exactly how that tornado is going to move. Because we build, and I'm going to scan through this pretty quick, we're building distributed systems with lots of external dependencies, which mean we have complex systems. And when you throw into that, the fact that your systems are changing super, super quickly, you end up in a little bit of chaos. So what we need is mechanisms, processes to help us handle the natural chaos and complexity of these modern systems that we are involved in and accountable and responsible for. Okay, and here's a message I like. Hope alone is not an option. This statement came out of a conversation I had with some lovely people who were, I can only say, at their wits' end. They were pretty much, they'd had enough of software engineering because they thought the world was terrible. They had spent millions on the right teams, the right observability platforms, the right management and monitoring systems, the right breakdown of services, the right decoupling, the right bulkheads, the right circuit breakers, you name it, they'd done it. The problem was they put all this together with their best intentions, and they still had interesting and fascinating failures that caused big problems for reliability and security in their system. And this was the sentence that sort of let them realize they should carry on with this industry, which is what they'd done is what I called hope-driven development. They put it all together and they hoped it would work, but they never exercised it or practiced it. Here's a question for you. If you're using circuit breakers, have you ever triggered 2 or 3 of those at once to see what happens in the real world? Those sort of questions let you know if you feel uncomfortable by that question, then you're using hope-driven development. Don't worry, you're not alone. Many, many people are. But what we're doing is going beyond hope, because we know we're building nonlinear dynamic systems made up of many people, many users, many different moving parts, clouds, tools, the whole shebang that's involved means you are likely in a nonlinear dynamic system. And when your systems are like that, we need to take a different approach to it, because everything is not predictable in that world. Okay, and the reason it's not predictable is because of this manifestation called dark debt. This thing that sits there that is in your system right now because of the nature of complexity involved, but you cannot design it out in advance. It's something you need to be better at reacting and learning from. Okay, So if hope alone is not an option, even reaction alone is not an option. What I mean by that is learning from crises, learning from incidents is very expensive. And if we just learn from those things, if that's the only feedback loop we've got, yes, we could argue we're injecting some resilience because we're learning from that at least, but we're not really learning from much else. And there's so much more we could learn from to be better at how we anticipate, not just react, but anticipate how the system might respond. So the key word in all of this is being proactive rather than hoping, rather than purely reacting. When you're engineering resilience into your culture, you're going to start to think about things proactively. What can we do now to be better prepared for later? And that's what is at the heart of resilience. What can we do now to be better prepared? And it's an investment. It's something that we put into a system in order to be better prepared later on, whether it be for reliability or security reasons, are the typical two cases. There are 4 capabilities that I think you should consider. This is where we start to become engineers. These are the 4 capabilities I want you to consider engineering into your software delivery systems. The first capability is anticipation. What is your capacity to anticipate? How good at you are at anticipating? And think about that for a second. How do you even know you're good at anticipating? You know, it's not just a measure of, well, we've got lots of alerts, we've got lots of logging. That doesn't tell you you've got much capacity to anticipate. What that tells you is you've got a lot of stuff that could happen. Knowing you're good at anticipation requires you to explore your anticipation, to start to prove it, to be scientific about it, to actually see it in action. In addition to anticipation, how good are you at synchronizing? How good are you at rallying the right resources for a given situation? How, you might have seen that in incidents and crises and surprises. You might get some degree of confidence that the right people are generally brought to bear and the right systems and tools are brought to bear on a problem. But again, if you're going to invest in resilience, you're going to do some of this proactively. You're going to proactively explore how you synchronize. The third one is looking at how you respond. What are your responses like? How good are they? How quick are you at responding? What is your MTTR? There are lots of other metrics as well that can give you fabulous senses for how good you are at responding. But again, that word proactive, you need to proactively explore how good you are at responding in order to be more resilient. The last one is learning, right? When anything happens to your system, how good are you at socializing that information, getting it out there into people's minds, helping people learn from it? Again, you can measure these things. One of my favorite measurements is as I said earlier, on an incident analysis. How many people are reading it? Just putting it available and seeing how many people actually visit it is a measurement, not of whether you've got people that should be told to go and read the incident analysis, but are you writing good incident analysis? A great incident analysis is like reading a story. Think about all of those TV shows you've watched that have taken you on an incredible journey of a disaster as it plays out. What about if your incident analysis had a little bit of that in it? You'd learn more from it if it was that interesting, and they can be. So resilience, as I say, is a collection really of learning loops that explore how you anticipate proactively, proactively explore how you synchronize, proactively explore how you respond, proactively explore how you might learn. Okay. And when we're doing these things, this is the sort of way we can have this learning loop. We have an outage, we go ahead and fix and diagnose and detect it, probably in the reverse order, and then we go ahead and learn from it. This is the kind of idea I want you to have in your minds of a learning loop. And this is one of the things I say to people, when you start to think about resilience, never let an outage go to waste, because it's an opportunity to learn. But if we're learning reactively, that's only half as good, if that, compared to proactively doing it. This is where we start to think about chaos engineering and engineering resilience into the system. We have capabilities, processes, and practices. And there are 7 capabilities I want you to develop. Bear in mind those 4 capacities that we want to establish in our system. Anticipation, synchronization, response, and learning. Well, these are 7 capabilities to explore, to develop those 4 capacities. This is what I do when I'm developing. If I want to improve how we anticipate, this is how I do it. I first of all define what good looks like for that particular situation. So what is good? How do we define great anticipation? How do we define great synchronization? Can we then observe it? And then I'll keep going around the loop in a second. So when it comes to reliability, if reliability is something you want to improve in your system, then let's define it better. Do you have SLOs? SLOs for me are one of the most fabulous tools you can possibly get your head around. I don't mind if you do SRE. I don't mind if you do the whole thing that goes along with SRE. That's not really what I'm here to worry about. But I love SLOs because SLOs give you the tools to begin to look at how we could be better. They are decision-making metrics, and they are wonderful for it. So get your heads around SLOs. They're underpinned by service level indicators. Those are the measurements of the actual system. But it's the objectives that give us the rationale for, okay, what does good look like here? And in this case, for reliability. So the decision-making tools, you go ahead and establish them. They define what matters. You don't have to be doing SRE. Okay, moving around the loop, if we wanted to improve the resilience of our reliability, observability is next, right? Can we observe being reliable? Do we know what the system is doing in any sense? Can we observe our SLOs? Again, I've lost count of the number of organizations who have SLOs, but no one can access them or even know where they are. These are things that the team will establish and should be soliciting. Now, there's an interesting fact here. I had a really big argument with someone once where they said the team should create SLOs and no one else should get to see them because no one else should be using those SLOs to in some way blame that team. And I said, okay, that's interesting. That's a cultural opposite of where I'm coming from. When I create SLOs with a team and teams, I will make sure everyone's aware of them because they tell everybody else, this is what we're aiming for. It's an objective. It's not an SLA. It's not what we're going to be contractually bound to, but it's telling everyone this is what we're aiming at. We're going to look for trends around this. And another interesting thing that I think is important is that SLOs for the different parts of a system, they obviously have relationships to each other to some degree. So if one part of the system is perhaps getting closer to breaking its objective, not meeting its objective, then other systems being aware of that might be useful to them. It's another decision-making possibility for them. So if we hide these things away, we lose so much learning and opportunity. So yeah, make sure they're open to everybody. Everyone should be able to find their SLOs, define them, and be able to collaborate on them. They're not islands at all. Okay, you've got your SLOs, so you can define, you can observe, you can see what's going on. What you can't do then is just sit back and go, well, let's wait for the crisis to happen. Then we'll know, aha, we saw it coming. What we do now is get proactive. We start to explore these things. And this is straight into the chaos part of the talk title, all right? Abandon hope. We don't need hope anymore. It's a good way. Abandon hope in a good way. What we want to do is make sure we use chaos engineering to explore what happens if. What happens if? Over and over again. What happens if? For example, we might run a game day or a chaos experiment to go, okay, this happens. What happens to the system? What does it look like? How do we respond? What is it really like? This is empirical experiments that you're running to then go, okay, this is how we can learn from this. This is how we can be better. Again, doing it proactively. And you can do them right across the stack in every facet of the system. It's absolutely crucial that you don't limit resilience or chaos experiments purely to the technical. You know, some of the biggest learnings I've ever had have come from looking at turbulence that was injected because somebody was taken out of the loop. Somebody's on holiday. See what happens. That type of thing is fascinating when you're looking at how systems react and respond and anticipate and synchronize. Chaos experiments will surface dark debt. They give us a means of continuously validating the system and helping us continue to explore. Okay. And it enables, importantly, enables us to practice and explore before any crises. Okay, it's the opposite of hope, and it's much more than purely failure injection. Okay, when you combine those two things, you've got SLOs and you've got chaos experiments, you've got some of the biggest answers to what experiments should we even do. Do experiments that explore the impact on your SLOs. See what happens to your reliability SLOs when an actual turbulent condition arrives in your system. What we do is we convert what was purely, when you look at the chaos engineering literature, we talk about steady state hypothesis. If you replace that with SLOs, because you've done the work, you've introduced SLOs as a measurement of reliability, then you can explore the impact on them using chaos experiments. Okay, once you've explored, you would hope you would fix and improve the system. And of course, we tend to introduce all sorts of technical ramifications to improve the system. I won't go through them all, but one of the key ones I like to highlight is reversibility. Can you go backwards, or can you go forwards in a sense that things will revert? Can you do that on your system is a great question to ask. Okay, fix and improve is done. Can we then verify it? So there's something else that's a new sort of label for a practice that says, if you've got your tests, your experiments and your chaos experiments, if you've already got them, you can enable them to continuously verify your system. I'll give you an example. We're held to certain constraints in the system I work on things like auditing. Now, auditing can be seen like a bugbear. Someone comes along and says, have you gone through the checklist? Are you right? And you can take the attitude of, well, I'll tell you what I'll do. I'll react when they turn up. And when they turn up, we'll do a project to fix the problems they find, etc. Right? That's a reactive approach. That's not resilient. Resilience says, okay, we want to be better at anticipating, synchronizing, and responding to these things. And maybe we can be proactive about this. So I create chaos experiments that match the criteria that an audit is looking for. So when my auditor turns up, I can turn around and say, we are already exploring the things you're looking for because we value what you're thinking about. We're doing the work already. We didn't just take the stuff you said and say, wait for the policeman to come back round again. What we're doing is getting way ahead of the game and exploring these things because we can see what you're looking for is important to us as well. Okay, that loops back round to learning. And as I mentioned, the key measurement of learning success is who's paying attention. If you don't have people that can write up incidents in an entertaining and interesting way, it's a very good investment. I found this a number of times now. A dry incident analysis does usually gets ignored, gets sat on a shelf somewhere, and is pointed out when people say, did we learn anything from that incident? Much better is to find a really entertaining incident analysis, which people are actually starting to share amongst each other because there's so much to learn from this. Okay, so quick summary. Resilience is crucial to providing reliability and security to your users when you are building complex, dynamic, non-linear systems. It's developed through focused, purposeful, proactive practice for developing the 4 capacities of anticipation, synchronization, response, and learning, making sure those learning loops are there. And we can develop those for these different things, such as security and reliability, by creating these loops of practices of finding, observing, exploring, fixing, verifying, learning, and continual practice. Chaos engineering is one part of this mix. It's the mindset of proactive exploration is a key part of those 7 different processes you can apply to develop your resilience. And there's one last thing to mention before I think I'm probably out of time. I haven't seen Bill panic yet, but it may be coming. One key thing, and I want to, this again, I've talked about culture in this talk, which is again a challenging subject for engineers, right? We tend to sit there and go, that's the sort of thing managers say, and we're not really interested. The other one that's often said by other people we don't care so much about is this word, which is empathy. I hammer on about empathy because resilience, developing resilience, encourages us to develop a culture of empathy. Because as I mentioned earlier, the story about the auditor relationship to the engineering team in a bank is usually one of policemen and criminals. You don't want to be caught by them because they're going to create work for you. But what is useful is if we flip that relationship around and empathize with the auditor, that the auditor is looking to help us because they don't want us to get full foul of regulations. Then what we can do is through resilience techniques and culture, like I've just mentioned, of going, okay, there's a set of constraints here. Let's embrace them. Let's thrive on them. Let's actually make them something we look for ourselves rather than waiting for someone to tell us we should have. And I mention empathy really here because I think it's the undercurrent and the heart of everything that I teach people to do within in engineering systems design. Whether I be an engineering manager or a lead engineer or whatever I do, empathy is at the heart of what I try to develop in the culture we have. Because every time someone empathizes, we end up with a better system. I'll give you an example. Continuous delivery is empathizing with the need to deliver the right thing to a customer. It's DevOps is empathizing, either the development team empathizing with ops or the other way around or both. Most of the biggest, the most important moves in our industry right now, as far as I'm concerned, have empathy at their heart. And here's the nice thing about empathy. As an engineer, empathy can be engineered. It's a skill. It can be learned. Anyone can learn to be empathetic. That's for a different talk. That's for a different subject time, but it's something I'd like you to consider because it's the heart of what I do when I'm working on all of these different types of things in my day job. I look at empathy as being the heart of humanistic engineering, which is what I look at when I'm putting these systems together. Resilience is something that comes directly out of making systems better for humans to inhabit as well as consume. Okay, I think thanks for your time. I just want to one last thing before I dial out, which is to say to people, if you are interested in getting involved in our little team at work, we are hiring. We're always going to say that. We are hiring. So if anyone is interested in joining me and working on these sorts of things on a daily basis, helping people like Save the Children and the UN get money around Africa, where it's absolutely needed, you are welcome to come and talk to me any way you want. And as I said before, anybody who wants to ping me, the first people that ping me, I will have to be limited to the first one or two. I will try whatever means I can to get you a copy of one of the books that you prefer to have. So please reach out either on LinkedIn, email, any way you like. Just give me a shout. And yeah, last thing, just check out that link at the bottom if you want to come work with us. Cheers. Thank you very much. Have a fabulous, fabulous rest of the conference.
Thank you, Russ. Much appreciated. I'm just checking to see if we have any questions here. I show up in the Pine app for you. I'm not seeing any, but I'll give people a few minutes here before we let you go on with your merry day.
It is sunny, by the way. It's sunny here in the UK. I want to point out that hell does freeze over.
It's sunny in November in the UK.
Yes.
It's almost an impossibility. It's a minor miracle.
Somebody would say there's climate change or something happening, but I don't think so.
No, you just got lucky. Just for you, Russ. All right. I'm not seeing any questions. Thank you so much, Russ, for the talk. As always, you speak to my heart around place. Stuff fails. Let's just make it not fail so painfully. Anyway, thank you much for the talk.
Absolutely. Thank you, everyone. Cheers.